Hello everyone, welcome back to my channel. Today I'm going to talk about the OAPI tool for SAP 2000, and I will use the Python code to apply in this video. So first you can check the OAPI documentation in the SAP 2000 installation folder, and you can read the information in this documentation. So I would like to show you the example 7, which is for the Python language. And in order to use this tool, you need to install the library, and you can just copy and paste it into the command prompt of the window, or you can just copy the last part of this command and just paste it into the console window in your IDE and install it. But I already installed, so I'm not going to install it again. And this is the code for the example 7. So you can copy this code and try to run it. So I already copy and paste it into this file, and I will run this to show you what this code does. So I will run here. So this code will open the SAP 2000 application and then create the material, the section, and then model the frame, and it will run the structural analysis and then export back the result to the Python code. And you can see here, this is what they want to show you. And this is the value of the result. So we have the result from SAP 2000 and the independent result in this code, and then the differences of the two results. And the result here is the displacement value, and you can check what where is that displacement. So this is point number 2, point name 2, and you can check here point name 2 from the frame name number 2. So you can check what is frame name 2, and so this is the frame name 2. It actually the second member in the structure. So this is what the code does, and I will use the same method, but I will applying to this 3D truss, which has the load here in this table, and also the Young modulus here. So in this video I will use the API tool to run the structural analysis and then import the result export the result from SAP 2000 to the Python code and show the result there. And this is the code that I did. So it actually not so much different from the code from the documentation. But okay, first I will clear this. And in case you didn't know, I have run the structural analysis of this 3D truss structure in my previous video, and this is the code that I used in my previous video, which is based on the direct stiffness structural analysis method. And I will show you the result here. So this is the 3D truss with the undeformed and deformed structure, and we have the result of the axial forces, the reaction forces, and the displacement at each node. So the objective of this code is to show the same result from my previous video, but this time we will use the SAP2000 to run the structural analysis, and then export back the result in this code. So first I need to import two important library. So the first one is Math, and the next one is NumPy. And in this code, this is actually an option for you to choose. If you already run the SAP2000, you can change this to true. The program will know that you want the code to open the program that already running. But in this case, I want this to open another window of the SAP2000. So we choose this false, and you can also specify the path of SAP2000 in your PC. So if you have a different version of SAP2000, you can specify the path in this line. But in my case here, I have only one version of the SAP2000, so I will choose this false. And this is the path that the program, the code create the SAP2000 model. You can change this just in case that you want to save the model into the to other location in your window. And for the code here, I will not specify much, because this is just the code that used for the option here and this one. So I will not, you can read this, but I will not talk in detail about the process here. Next, this is for create the SAP model. So in 3 command here, the code will create a new blank file of a SAP2000 file for you to model the structure. And next we need to create the material. So the first one here, the material equal to 1, it means that it create the material following the order of this list. So if you want to create for example a code for material, this will be a number 4. So you start from 1 2 3 4. So you need to change this to 4 if you want to create a code for material. But in this case I want to create a steel material, so I just put this 1 and I name this other, and this is the property of the material. And in this case I only change the Young modulus, because in our example the Young modulus is equal to 10,000. So I put 10,000 here. and the default unit is this one, so I will keep like that, so I don't have to worry about this value. And next one, we need to create the section. So this is the section property. We have the name of the section, we have the property of the section, and this is the width, and this is the depth value of the section. So when you multiply the width and by the depth, you will get the area of this value. So that's why I used the square root function here. And the section here is the rectangular section. That's why we have the width and depth of the section. And we have the section property modifier. We can change the value here, but I will keep this one all one. And in order to set the property modifier, you can use this command. First, you define the section that you want to set the property modifier, and in this case it is all1 because our section name is all1, and you put the value here. And this is the unit. Again, this number is the order of the list, so in this case it's 1, 2, and 3. And the next part is we need to add the point. So I use the same array from my previous code. So I don't want to write another line just because I want to make the code. I mean I want to write the code faster, so I just copy and paste from my previous code, and I use for loop to create a point load by using the API tool command here. So the first point is x axis value, and this is y axis value, and this is for z-axis, and this is the name of the node. So this is the string type. It will convert the value the number here. So the first node will start from number 1 because we add the value here 1, and it will run until the end of the the last node, and in this case is node number 10. And the same for bar array. I copy this from my previous code, and then I use for loop again. And first we need to specify the first point of the bar, and in this information it starts from 0, but our bar here start from 1 to 2, so I use the summation of the original value here by 1, and convert this to string, and this is the end point, and this is the name of the bar, and this is the material of the member. Next we can set the support of the structure. And okay, first we need to set the support type. So we have true, 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 and false, false, false. This mean sorry, these are for the displacement, and this is for rotation. So our supports are pin support, so the displacement will be restrained and the rotation is free. So in order to set the support, you can use this command and set where are the support located. So it will add the node numbers 7, 8, 9 and 10. So this will be 7, 8, 9 and 10, and we use the value restraint. Next we need to release the moments and rotation of the bars, actually all the bars in the model. But first we need to assign the value, the property of the release type. So the II array here represent the first point of the member, and this is for the end point of the member. And if you notice here, this is true and this is false, because we cannot release both torsional value of the first and the end point of the member, because if we do that, the structure will not be stable. And the last two value here is for the moment, so we release both the moment M2 and M3. And the start value here represent the partial fixity, but in this case we not use the partial fixity, so the value here are all 0. And in order to release all the member, I use for loop. It will run from 0 to 24, and the number of the bar here will start from 1, so I add 1 here, and this is II, JJ, and start value and end value. And next, this is for refresh the model view, and this part is for add the point node. So first we need to add the load type, and this one again, it is the number of the order of the load here. So I use the adder type of the load here. So this will be value 8, and the self-weight multiplier is the value here. This is 0 because I don't want to include the self-weight in this load type. And then we can add the load number 1, number 2, number 3, and number 4 following this table. So we can import the value here. The first 3 value is for fx, fy, and then fz, and the last 3 value is for the moment. So this load will be assigned on the node number 1, 2, 3, and then 6, and the value 1 here is the name of the load pattern. And next we save the model and then run the structural analysis, and then we can export the result from SAP 2000. So the first one I add here is the axial force array, and then for the array for the reaction force, and then for the displacement. So the axial force is all for all members, so it will be number 25, and this will be a two-dimensional array with 4 row and 3 column, and this is also the two-dimensional array, but we have a 10 row and 3 column. And this line is for this select all case, and also the combination of the load case, because we want to show only one selected load case, and in this case it is the load number 1 here, so I put number 1. And this is just a parameter in order to export the data from the SAP 2000. So we use some command here in order to import the frame force, and for frame force we have the axial force, the shear force, torsional force, and the moment, the bending moment. And I only import the axial force to the axial area here, so I set axial, I set the command like this, and this is for the reaction force and the placement. And then I add this code in order to make the program close by itself, and this is where I print the result. So in order to import the load from SAP 2000, you need to add some command here, like the load case, the step type, step number, and some parameter here. And you can read this by using the OAPI documentation. You can just search for anything like join, frame, basically anything that you need to use for your project. So now we run this code. So the code will open the SAP 2000 software, and then again create the material, the section, and then model the frame, run the structural analysis, and then export the result to the Python code. So it will close itself, and this is the result. And now you can compare this result to the result that I ran from my previous code that I used the direct stiffness method. So this is for the first member. The value is 1.91, so this 1.91, and you can check the other value for each for other member as well, like the last one here, minus 15.81, so this one. And you can check the reaction force with the reaction force here, and also the joint displacement with the value. So this is how we can use the API tool in order to use the SAP 2000, run the structural analysis, and then export the result back to our code. It's really useful and can be used in many areas, in many research. So I hope you guys get the idea of this video, and you can I hope that you can do it by yourself, and I recommend you can just use this documentation because it's really useful. And this is it for my video. Thank you guys for watching. I'll see you guys in the next video.